Hey guys, we're getting ready to start our flip video on weather. So we're going to first look at the objective that we have for this. It's 7.E.1.3. Basically in this, you should be able to explain the relationship between the movement of air masses, high and low pressure systems, and frontal boundaries of storms and other weather conditions that may result. So basically we need to understand how air moves in our atmosphere, especially the layer closest to us, the troposphere, and how those frontals and boundaries and air masses actually give us severe weather. So first we have to be able to define what is an air mass. All right, the definition is a huge body of air that has similar temperature, humidity, and air pressure. So if we were to take a look at our United States and one big chunk of air resting over top of it, that air mass would have similar temperature, humidity, and air pressure. Okay, air masses usually take on the characteristics of where they originated. So if it originated in a cold area like Canada, it's going to be a uniform air mass of cold air. If it developed over warm water, it is going to take on the characteristics of very moist, humid air. There are 4 types of air masses that we're going to look at: polar, tropical, maritime, and continental. So we'll go ahead and take a look at the two that sort of are opposites of each other. So the polar air mass versus the tropical air mass. So in a polar air mass, these originate at latitudes of 60 degrees north and south. So if we think of latitude, it's 60 degrees north of the equator or 60 degrees south of the equator. They're usually cold, hence the name polar. All right, tropical air masses originate at latitudes within 25 degrees of the equator. So if we use the equator, 25 degrees north of that, 25 degrees south is where we get these tropical air masses. Okay, these are usually warm air. So a polar air mass, cold, forms far away from the equator. Tropical air mass, warm, forms closer to the equator. Maritime versus continental. I'm hoping you know what continental means, but maritime is associated with the ocean. Okay, it originates over oceans. It's usually moist air. So when we talk about polar versus tropical, we're talking about cold versus warm. Maritime versus continental, we're talking about moist versus dry. So continental air masses originate over large land masses, usually the continents. All right, and this is usually considered dry air. We can combine those things to create different air masses. So for example, we could have maritime polar. That would be moist, cold air. Okay, so it could form off of a body of water that is cold, like the Arctic Ocean, hence the maritime. All right, moist air because it formed off an ocean, cold because it was originated in a cold place. We have maritime tropical. Those would be moist and warm air. We have continental tropical, dry and warm air. And then we have continental polar, that is dry and cold air. And so we can use these interchangeably to describe the air masses over the United States. So let's take a look at where these are located on a map of the US, and you'll fill these in on the map that you have in front of you. Okay, so you can see over here off of Alaska, coming down from Canada and places like that, we are going to get this maritime polar, where it is going to be moist, cold air. Okay, down here in the southwest of the United States, we have the Pacific Ocean. This is going to be maritime tropical. It's going to be very moist, warm air. Why? It's closer to the equator. This formed far away from the equator. Okay, over top of Canada right here, you have continental polar. So that is going to be dry, cold air coming from Canada. All right, you have continental tropical coming here from places like Central America, Mexico, places like that. Formed over top of land, but it is warm, so this would be dry, warm air. You have this maritime polar towards the northern part of Canada. It forms off of an ocean, so it is going to be moist, but it is going to be cold because it's polar. And then maritime tropical down here, you are going to have nice, warm, moist air coming from that location. Okay, with this air, when it moves, it produces something called fronts. Okay, a front is a boundary where 2 air masses meet. All right, and we're going to talk about the different boundaries that there are and how those are used actually to predict weather conditions. Fronts can be identified by looking at changes in temperature, air pressure, humidity, and changes in wind direction. So if you think back to that lab that we did, we were looking at those weather symbols, looking at changes in air pressure. We were looking at changes in wind direction. We were looking at changes in temperature and humidity. Okay, all of those are formed because of a front. There are 4 types of fronts that we're going to look at. There's a warm front, a cold front, a stationary front, and an occluded front. So we're going to first talk about a cold front. A cold front occurs when cold air comes and displaces or replaces warm air that exists. Okay, so cold air comes in, it moves out or takes over that warm air that was in place. Okay, cold fronts move quickly and cause fast weather changes. This is the symbol that you would see on a weather map if you were to watch the news. All right, it is blue triangles to represent a cold front. And here is what this looks like on a diagram. Okay, so the warm air was in place right here. It is being pushed out by this cold air, and you can see this is the direction of the frontal movement. On the map, here is the symbol being used to indicate that. All right, and we will get cloud development because this cold air is lifting this moist air up, which does create clouds. Okay, a warm front, I've given you the symbol here. All right, notice a warm front are now these half circles. Okay, a warm front occurs when warm, less dense air climbs over cold air. So warm air is less dense because it's taking up more space, all right, than cold air, and what it does is it climbs over a cold air mass. So you have this warm air coming in behind cold air, all right, a receding cold front, still moving in this right direction. The warm air is going to lift up over the cold air because it's less dense. Cold air is more dense, so it's going to sink down, all right, and developing this moist air over top of it. And again, you can see the symbol here that would be used on a weather map to represent a warm front. Okay, warm fronts move very slowly, all right, and because it does move slowly, it could be rainy or cloudy for several days. All right, after it passes, the weather is warm and humid. All right, so after it does pass, you will get that nice, warm, humid air, typically what you think about when it's summertime in North Carolina. Okay, a stationary front, the word stationary means to stay in one place. All right, so a stationary front, here is the symbol that would be used on a weather map. Okay, stationary, you can see it's half a warm front, half a cold front, half a warm front, half a cold front, because that's exactly what's happening. Okay, warm, 2 air masses are along this boundary, but neither one is moving. They're stuck, all right, they're stationary. Precipitation forms at the point where they meet. So cold air is moving in, warm air is moving in against it. They get stuck and go nowhere, and clouds form, which then causes condensation, which when those clouds get too heavy, it precipitates, and that just continues until one air mass wins out. Okay, but a stationary front is exactly what happens. It stays stationary, and you get precipitation as part of your weather. An occluded front, and you can see the symbol that would be used on a weather map. Okay, we've got cold front and a warm front sort of working together here in places. All right, this happens when cold air masses cut off and lift up a warm air mass. Okay, the word occluded means to cut off. Forms clouds and possibly precipitation when this happens. Okay, so you've got this very cold air, the receding cold air behind it. Okay, receding cold air ahead of an occluded front. So we've got cold air moving out, cold air moving in. So 2 cold air masses sort of meet and cut off all the warm air and force it upward. So all of this warm air gets forced upward. Clouds are going to form, and through the process of the water cycle, precipitation would eventually take place. So what's the relationship between air, water vapor, and temperature? When warm air has less water vapor, it'll produce clouds. Okay, so if there is warm air but not a lot of water vapor, you're going to get cloud cover outside on those days. And if it has a lot of water vapor, we could actually produce thunderstorms. After a cold front moves through, the temperatures will be cooler and the air will be dry. So warm fronts, when they move through, could cause precipitation because of the amount of moisture. Cold fronts, when they move through, drop our temperatures and make the air more dry. So now we have to talk about pressure systems. So how do these air masses get moving? It all has to do with the pressure that is in the troposphere, okay, the air pressure. And we have 2 types of pressure systems we'll talk about. All right, so basically to define a pressure system, the amount of air pressure is how much the air in the atmosphere is pushing down on the surface of the Earth. Okay, so how much pressure is the air putting on the surface of our planet? There are 2 types. It's either high pressure or low pressure. Okay, so let's first talk about a high pressure system. If it's high pressure, that means the air is sitting low, close to the surface, pushing down on the Earth's surface, okay? So high pressure because the air is low, producing a lot of pressure. Okay, so the air is low. That means that we have lots of pressure. We get a high pressure system. If the low pressure system is in place, that means that the air is actually really high. It's not putting pressure on the surface. All right, so if the air is high, that means that the pressure is low. We have a low pressure system. Okay, a high pressure system is called an anticyclone. Okay, and in a high pressure system, high pressure centers of dry air that formed at frontal boundaries and is associated with dry, clear weather. So if we have a high pressure system moving through Raleigh, North Carolina, we're going to have dry conditions and it's going to be relatively clear. All right, nice blue skies. If we were to look at this at a diagram, okay, a high pressure system, that dry air, all right, the high pressure system is going to push air out. This other air is going to get pushed into this high pressure system, which is actually going to cause things to be relatively nice weather-wise. In a low pressure system, this is just called a cyclone, okay, a swirling center of low pressure air which forms at frontal boundaries and brings clouds, winds, and precipitation. Okay, so you'll notice the opposite picture. In this case, the air is moving into the pressure system, right, converging down here, whereas the air is being pushed out the top. In the high pressure system, the air was being converged down in, which was causing it to be pushed out divergently down here at the bottom. Okay, if we were to show this side by side, what it looks like, for a high pressure system, cold air sinks and the winds diverge out. All right, in a low pressure system, converging winds come in and push that air up, which creates stormy, cloudy weather. Okay, so clear, calm weather for high pressure because the cold air is sinking in, causing winds to be lower to the surface, whereas low pressure, winds are coming in and being pushed up, causing cloudy, stormy conditions. Okay, with these cloudy, stormy conditions, we can get thunderstorms and tornadoes. Okay, thunderstorms form in large cumulonimbus clouds. We'll get into clouds a little bit later. When warm air is forced rapidly upward along a cold front. Okay, so we get thunderstorms and tornadoes when we're talking about a cold front. Okay, tornadoes form when a warm, humid mass meets a dry, cold air mass. So we have warm, humid air meeting with cold, dry air, causes things to be unstable. All right, warm air is forced upwards along a cold front to produce several thunderstorms, which can turn into a tornado. Okay, there's a place in the United States called Tornado Alley, which usually sees upwards of 800 tornadoes a year. Okay, tornadoes are dangerous because they are so unpredictable. We also can get hurricanes. Just recently with North Carolina, we experienced a hurricane this season. So how do they form? Okay, they form in the Atlantic, Pacific, and Indian Oceans. The strength of a hurricane comes from the warm, moist air of the ocean. Okay, so typically hurricanes occur between the months of June and November. All right, in the Atlantic because the water is so warm. Hurricanes form around a low pressure system. Okay, low pressure system, all right, where the winds are coming in at the surface and pushing all of those winds upward. All right, as the area grows in size and strength, it forms a tropical storm followed by a hurricane if it continues to grow. Okay, and we're going to study each of these a little bit more in depth as we go through our unit.